There we have a setup which we are required to determine or to solve some problems. And as soon as we have a vector problem with a grid, we know that our work is greatly simplified. We do not mind. For the vectors in this section, we will make use of movements on the grid. Right? So that is what we are making use of. Movement on the grids because the grid is present and that makes our work easier. So we have OA. All we need to do to find the vector OA is take a look at the movements from O to A. So we have an X component and a Y component. To move from O to A, we say -1, and then we go up by, what do we go up by? 1, 2, 3. So 3. So that is -1, 3. Notice that we are going in negative X direction. What about OB? Here. X movement 1, 2, 3, 4, 5. Although we can plainly see that it is 5, we are just counting 5 to get our minds prepared for when we are not beginning at the origin. So 5, and then we go up by 1. So 5 there, and then we go 1 there, so 5, 1. BA also based on movement, but this time the number of units are not counted from the origin because we are not going from O to anywhere, we are going from B to A. We will begin at the beginning, which is B, and finish up at the end, which is A. So BA begins at B and ends at A. So look at the X movement. 1, 2, 3, 4, 5, 6. 1, 2. And sometimes my students are saying 6, 2. And I'm waiting for them forever to say -6. And they will not say it, and I will not give them the answer. I stay there and wait until they supply the correct answer, which is -6, 2. Then I move on. And if they do not, then we do not move on. So -6. Because we are going in the negative X direction, 1, 2, 3, 4, 5, 6, and then we are going 1, 2 in the positive Y direction, so that is -6, 2. What do we have there? We are given the information in the statement of the problem that G is the midpoint of AB. And we are saying from A to B, the horizontal movement is 6 units. The midpoint of AB must be located halfway between A and B, which is what? A horizontal distance of 3 units. So we have, this is 6 units. So anything that is halfway between A and B, we have 1, 2, 3, 4, 5, 6 units. So anything that is halfway between A and B must have 3 horizontal units from A and 3 horizontal units from B, halfway. So 1, 2, 3. So right there. Right. So there is where we will have located the point G. And proceed as before in finding the other vectors. So we need BG. Stay at B, then move to G. So we have what? From B to G we have 1, 2, 3, and -3, because we're going in the negative X direction. It is not a location, it is a movement. And then we have what? 1 unit. So we go up by 1. Positive Y, 1. So -1, -2, -3 for the X, and +1 for the Y. We could have also made use of the fact that BG is half of BA, right? So BG is half of BA. So what we have for BA, we could have said half of -6 is -3 and half of 2 is 1. So we could have done that. What do we have? OG, that's the next one. To go from O to G, we go 2 units here, and then what? Another 2 units there. The computer had me, I would say, blindsided a bit, but because they are both 2, then in the end, I was not defeated. Remember that moving to the left is negative X movement and downwards is negative Y movement. So if the movement would have been in the direction going down, that movement would have been a negative Y movement. And as long as we are going to the left, that represents a negative X movement. So we are to be careful when we are making our movements and representing them in a numerical way, because we need to be aware of the implications of the direction as it pertains to the signs. Now we will finish up with our matrices. First of all, we need to have L plus 2M. That is what we need. We have L and we have M. To find L plus 2M, we do 2 times the matrix M and add it to L. So 2 times 1, -1 is -2, 2 times 3 is 6, and 2 times 2 is 4. No doubt, 2 times 0 is 0. Now we need to add these. -2 to be added to 3, we have a +1, then we have a +8, 2 plus 6 is 8, then 1 plus 0 is 1, and 4 plus 4 is 8. But we need to be mindful of the fact that when we are just adding matrices, we just need to add the corresponding values. 1, 8, 1, 8. So 3 plus -2 is 1, 2 plus 6 is 8, 1 plus 0 is 1, and 4 plus 4 is 8. That's all there is to it. The product is a little bit more sophisticated. We need to find the product of those 2 matrices. So we row by column, row by column, and row by column. So we say 3 times -1 plus 2 times 0. There, 3 times -1, 2 times 0. The upper with the left, the answer goes to the upper left. So 3, -1, 2, 0. Then the upper with the right, the answer goes to the upper right. So 3 3s, 2, 2. 3, 3, 2, 2. Then the lower with the left goes to the lower left. We have 1, -1, 4, 0. 1, -1, 4, 0. The lower with the left. Now the lower with the right, the answer goes to the lower right. So we have 1 with 3 plus 4 with 2. And then when we simplify that, we get what? -3 here. And of course, 9 plus 4 is 13. Then we are just taking advantage of the fact that these will turn out to be 0. So we have a -1 there. And we have what? 3 plus 8 is 11. So -3, 13, -1, 11. Just manipulating those matrices can be fun. Now, we need to find the inverse of Q. And to find the inverse of Q, we have Q right here. We do what? 4 multiplied by 1 minus 2 multiplied by 1. That's what we have there. So 4, 1 minus 2, 1. That is 1 over what we call the determinant. This times this, this times this. So we subtract, and that is what we call the determinant. This minus this. So 1 over the determinant, and we multiply by the adjoint. And the adjoint is formed by exchanging the places of these two and changing the signs of these two. So there we have 4 minus 2 is 2, so a half there, and half to be taken of each one of these. So a half of 1 is half, a half of negative 2 is negative 1, a half of negative 1 is negative a half, and a half of 4 is 2. Now we have this equation. Notice that we have this matrix equation, and notice what we have right here. The same matrix Q. Therefore, if we need to find x, y, we need to eliminate this from the left hand side by multiplying by the inverse of this matrix. Therefore, we multiply by the inverse of this same matrix on the right hand side. Of course, doing that will cause the 4, 2, 1, 1 to be eliminated from this side, and on the other side we have what? The inverse of the matrix being multiplied. Alright, but instead of using the matrix as we have found the inverse right here, instead of using it right as we have it there, we kind of take the half outside, so that when we are multiplying we just use whole number, and then we take half of the entire thing at the end, because it is always easier to manipulate whole numbers than fractions. And I think that the examiners will be delighted to see that students do not just jump and just use the fractions and make a meal of the problem, although it is not impossible to manipulate those fractions and get it right. But we can eliminate any what we would call shadow of difficulty by taking the half right here, and we do the same row by column. So this times this, this times this, and then this times this, this times this, and there we have it. So simplify these, and what do we get? We get 2 here, because 8 minus 6 is 2, and negative 8 plus 12 is 4, and we know a half of 2 is 1, and a half of 4 is 2. X is equal to 1, y is equal to 2.